In this last set of problems, we solve applications using quadratic equations. The period of a pendulum is the time it takes for it to swing back and forth. The formula L equals 0.81 t squared relates the length L in feet of a pendulum to the time t in seconds that the pendulum takes to swing back and forth. A. Solve this formula for t. B. Find the period of a pendulum that is 3.6 feet long. And C. The longest pendulum in the United States is located in the Convention Center in Portland, Oregon. The pendulum's length is 90 feet. Find the period of the pendulum. For part A, we want to solve the formula for t. And as we begin this problem, I'm going to go ahead and switch sides here so that my t is on the left side. So I have 0.81 t squared is equal to L. Now the next step will be to divide both sides by 0.81, giving me t squared is equal to L over 0.81. The next step is I'm going to take the square root of both sides, and normally I would take both the positive and the negative square root of the right side, but we're talking about times, so we're dealing with only a positive number. So t will be equal to the square root of L over the square root of 0.81, which is equal to the square root of L over 0.9. Now for part B, we want to find the period of a pendulum that is 3.6 feet long. So we're going to take our formula, t equals the square root of L over 0.9, and we're going to put 3.6 in for L. So we've got the square root of 3.6 over 0.9, and that's approximately equal to 1.9 over 0.9, which is approximately equal to 2 seconds. Now for part C, we know that the longest pendulum in the U.S. is located in Portland, Oregon. And we know that the length of that pendulum is 90 feet. We want to find the period. So we're going to use our same formula again. T equals the square root of L over 0.9. This time we're going to put in 90 for L. So we have the square root of 90 over 0.9. Now that's approximately equal to 9.49 in the numerator over 0.9, which is approximately equal to 10.5 seconds.